Well, good evening. Good evening. Great to join you this evening. It's quite an honor for me to come speak to the friends of science, the geologists, the great scientists who are here, and the guests. And it's a special treat to visit beautiful Canada.
We have arrived at a moment of decision. Our home, Earth, is in danger. What is at risk of being destroyed is not the planet itself, of course, but the conditions that have made it hospitable for human beings.
Scientists are more certain than ever that burning fossil fuels and cutting down forests are the two biggest driving forces of climate change.
Ladies and gentlemen, we live in a world of superstition. Just 10 days ago, more than 10,000 people marched in Washington, D.C., Toronto, cities around the world, all demanding that humans control the climate. And many of those people believe that if they change their light bulbs, they can save polar bears. Or if they build wind turbine towers, they could stop the oceans from rising. Or if we all drive electric cars, we can make the weather and storms less severe. I call that climatism, the belief that humans are causing dangerous global warming. And the theory of man-made warming is accepted today by more than 190 heads of state, by all of our leading universities, the United Nations, the news media, the major scientific organizations of the world. And the world is spending over $250 billion a year to try and stop the planet from warming. The theory of man-made warming is based on 4 principles. The first is the greenhouse effect. Sunlight enters our atmosphere, it's absorbed by the surface of the Earth. Like any warm body, the Earth gives off lower energy infrared radiation. A very small amount of that makes it out into space, but almost all is absorbed by greenhouse gases in our atmosphere. Those gases then re-radiate that energy, and that does tend to warm the surface of the Earth. The second basis is rising atmospheric carbon dioxide levels. Modern measurements of carbon dioxide were first made in the 1950s, and at that time scientists measured about 315 parts per million. Today that's risen to over 400 parts per million, and the proponents of the theory of man-made warming say this is due to our industries putting carbon dioxide into the atmosphere, adding to the greenhouse effect and causing the temperature to rise. The third basis is rising global surface temperatures. Temperatures have risen about a degree in the last 130 years, 0.8 degrees Celsius or 1.4 degrees Fahrenheit. And the fourth basis for the theory is computer model projections. Climate models are run on supercomputers like this one in England, and those models predict a much faster rise in temperatures, a rise of about 3 degrees Celsius by the year 2100 or 5.4 degrees Fahrenheit. And you've all heard about the coming disasters, of course, melting ice caps, rising ocean levels, flooding our coastal cities, stronger hurricanes and storms, droughts and floods, and many other effects. But ladies and gentlemen of Canada, there is no empirical evidence that increasing greenhouse gases are the primary cause of global warming. The Intergovernmental Panel on Climate Change of the United Nations has said the increase in temperature in the 20th century is likely to be the largest of any century during the past 1,000 years. Let's put that into perspective for a moment. Here's a bit of a complicated graph that shows Chicago temperatures for the last 140 years or so for each day of the year, from January 1st over here to December 31st over here. That blue curve at the bottom is our record cold temperature for each date of the year. The red curve at the top is our record hot temperature for each date of the year, and the gray bar in the middle is our average max and min. Our temperatures in Chicago vary about from -5 Fahrenheit to 95 Fahrenheit every year, about a swing of 100 degrees Fahrenheit or almost 50 degrees Celsius. So I'm going to superimpose on this the amount that global surface temperatures have risen in the last 130 years. There it is. It's captured within the thickness of that black line. That's what climate scientists tell us is a coming calamity and must be caused by our industry. We've all heard that the Arctic ice is melting, the glaciers in Glacier National Park are melting, The important thing to remember is that melting is evidence of warming, but it does not tell you what is causing the warming. I'm sure you've all heard the phrase, climate change is real. Hopefully none of you are using that phrase. That is a true statement, but it's a meaningless statement. Of course climate change is real. Climate has been changing for all of Earth's history. Two well-known periods of climate change are the medieval warm period and the Little Ice Age. The medieval warm period was a period from about 900 to 1300 AD, when the Vikings settled southwest Greenland. They founded a colony at Havasi, 600 years before the Jamestown colony. They farmed, they raised livestock, and that colony grew to about 5,000 inhabitants. And the historical work, the Book of Icelanders, said that in those days, trees were 6 meters or 20 feet tall in Havasi. But this is a picture of the old stone church, that site today, and there's nothing there but scrub grasses. It was warmer 1,000 years ago than it is today. About 1300, we entered a cooler period of the Little Ice Age. Not a true ice age, but a period when temperatures were 1 to 2 degrees cooler than the medieval warm period or today's temperatures. And that colony died out. Very tough time in Europe. Shorter growing seasons, famine. But every year they would have a festival called the Frost Fest on the frozen Thames River right at London. You can see that image over here. They'd bring their horses and wagons right out on the ice and build sheds and displays right out on the ice. Well, you can't do that today. The Thames River hasn't frozen solid for over a century. The medieval warm period and the Little Ice Age were two periods of natural warming and cooling, nothing to do with sport utility vehicles or power plants. If we look a little more quantitatively at temperatures over the last 10,000 years, this is data from ice cores, by the way. Start here at 0, present day, go back 2, 4, 6, 8, 10,000 years to the end of the last ice age. You see that temperatures rise and they fall and they rise and they fall. You can see the medieval warm period there and the Little Ice Age. And for the last 400 years, we've had a gentle warming as we've been coming out of the Little Ice Age. Now, my own U.S. government puts out statements like the decade from 2000 to 2009 was the warmest on record. Sounds very scary. But what you need to know is that the record refers to the thermometer record, which is only 130 years long. I'm going to put that up on the chart here. See that little green dot over there? That's the record. Wow, that is really scary, isn't it? That is very misleading. That ignores all the periods over the past 10,000 years when it was warmer than it is today. This image was contributed by your very old Tim Ball. This is a picture of a white spruce stump up in the Northwest Territory of Canada. It's a very old, in the north of the Arctic Circle, very old stump. It was radiocarbon dated to be almost 5,000 years old. But the interesting thing from a climate point of view is that this stump was located 100 kilometers north of today's tree line. 100 kilometers north of any other white spruce tree today, evidence that it was warmer 5,000 years ago than it is today. About 1,000 miles from here, you guys use kilometers, let's see, what is that? I don't know. To the northwest, we have the Mendenhall Glacier near Juneau. And very interesting, a group called thisisclimatechange.org put up posters in Reagan International Airport in 2008 showing the picture on the left with the real big Mendenhall Glacier in 1894, and then today very much smaller glacier. And the implication, of course, was that human industry was causing these glaciers to shrink. But just 4 years ago, scientists from Southeast Alaska University went down into ice caves under the glacier, and they found some interesting evidence. They found tree stumps under the glaciers. This, you can see one right here. It's about 1 foot in diameter, still had the roots in the ground. They radiocarbon dated this stump, and it was about 1,000 years old. It grew up during the medieval warm period. So the implication is, where we have a glacier today, 1,000 years ago we had a forest. It was warmer 1,000 years ago than it is today. New Jersey Governor Chris Christie has said, climate change is occurring and humans play a contributing role. Yeah, I agree with that statement, but that's another meaningless statement. Climate change is always occurring, and my little 12-pound dog is a contributor. The real question is, what is the size of the human contribution relative to natural factors? Because Earth's climate is complex. This is just a simplified diagram. It's shaped by powerful forces from the solar system, the atmosphere, the oceans, and the land. All weather on Earth is driven by sunlight. Sunlight falls directly on the equator and the tropics where much energy is absorbed, and sunlight falls indirectly on the polar regions where little energy is absorbed. All weather, storm fronts, hurricanes, jet streams, ocean currents, is forced to redistribute energy from the tropics to the poles. The oceans have a powerful effect on Earth's climate. The oceans have 250 times the mass of the atmosphere and can hold more than 1,000 times the heat. And then we have aerosols, volcanic dust, dust from deserts, pollen going up into the atmosphere that shape the climate. Yet today's climate scientists are obsessed with the level of carbon dioxide in the atmosphere, a very, very small part of the overall picture. Indeed, carbon dioxide is a trace gas. One way to think about it is to picture a basketball arena with 10,000 fans. Only 4 of every 10,000 molecules in the atmosphere are carbon dioxide. And the amount that humans could have added in all of our history is only a fraction of 1 of those 10,000 molecules. I know that many of you in the audience know the answer to this next question. But what is nature's most abundant greenhouse gas? Water vapor. What a smart crowd. It's not carbon dioxide. It's not methane. Nature's most dominant greenhouse gas is water vapor. Scientists estimate that somewhere between 75 and 90% of Earth's greenhouse effect is caused by water vapor and clouds. Remember, the greenhouse effect is what's blamed for dangerous man-made warming. So if we're conservative, we say 3/4 of the greenhouse effect due to water vapor and clouds. Then the last quarter is mostly caused by carbon dioxide, methane, and other gases. But then we need to ask, well, how much of this last quarter is due to human industry? Because the oceans hold 50 times as much carbon dioxide naturally dissolved as the atmosphere. And the oceans are always releasing carbon dioxide and absorbing it. When plants grow, they absorb carbon dioxide. And when they die, carbon dioxide is released. And then we have volcanoes, both above the surface of the ocean and about 10 times as many under the surface of the ocean, putting gases, including carbon dioxide, into the environment all the time. Every day, nature puts 20 times as much carbon dioxide into the atmosphere as all of Earth's industries. So if we roll that all together, that means that humans are responsible for about 1 or 2 parts per 100 of Earth's greenhouse effect. Who's heard that in the press? Nobody. We all hear about how our industries are putting greenhouse gas in the atmosphere, we're enhancing or causing the greenhouse effect. Yes, but our industries are responsible for about 1 to 2% of Earth's greenhouse effect. If we completely eliminate all emissions, we probably cannot measure the difference in global temperatures. And it's clear now that the climate models are wrong. Global temperatures have been just about flat over the past 20 years. Those 2 bottom curves, the green and the blue one, that's measured temperature data from weather balloons and satellites, fairly flat. The red line is an average of 102 climate models which have been predicting a much faster rise in temperatures. So it's clear now that we're not seeing dangerous global warming and the climate models are wrong. So one question that should be in your mind, well, how could all the world's climate models be wrong? Every climate scientist knows that carbon dioxide by itself can't cause dangerous global warming. The reason is that the radiation spectrum of carbon dioxide is nonlinear. The first carbon dioxide in the atmosphere absorbs most of that infrared radiation, but we're way out here now, 400 parts per million. You add some carbon dioxide, it doesn't do anything to temperatures. If we double atmospheric carbon dioxide, either through natural factors or through human industries, we'd only raise global surface temperatures by about 1 degree Celsius. That's all. Nothing catastrophic. But all of the climate models make an assumption. They all assume a positive feedback from water vapor. And the logic goes like this. Our industries put a little carbon dioxide in the atmosphere, they cause a little warming. A warmer atmosphere can hold more water vapor, which, as you now know, and I think you did before, is a greenhouse gas. That produces further warming. That's a positive feedback. But papers are showing that that is not occurring, and that the effect of clouds probably reduces the warming effect of carbon dioxide. This is all a little preposterous anyway. I call this the flea wagging the dog theory. Earth's water cycle is huge. Huge amount of energy, includes all weather, all of the oceans, all of the ice caps. And the idea that the much smaller carbon dioxide cycle is now controlling the water cycle is not very likely. So what caused the late 20th century warming? Well, if you look at recent history, you see that carbon dioxide and temperatures don't track very well. That red line is rising carbon dioxide. But global temperatures cooled from about 1940 to 1975, and then they rose from 75 to about 2005 or so, and since then they've been flat or cooling. Matter of fact, back in the 1960s, some of you may remember, we had the Ice Age cometh scare. Front cover of Time and Newsweek, and many professors were teaching that we had to prepare for the coming Ice Age. Well, the answer lies in that little body about 600 miles to the west of here called the Pacific Ocean. Covers 1/3 of the Earth's surface, and it turns out that the Pacific Ocean has its own temperature cycle. It was named in the 1990s to be the Pacific Decadal Oscillation by Stephen Hare, and he did that to explain the changes in salmon runs on the west coast. But it turns out the temperatures in the Pacific vary in a natural cycle of about 50 or 60 years. You can see a warming here to 1940, cooling to 1975, warming to 2005, and a recent cooling. So now we're able to explain from natural factors of how we've had the 20th century warming. And it's the combination of two factors. The first, we're having a long-term gentle temperature rise as we've emerged from the Little Ice Age. That's the regular dark line here. And then on top of that, we have the variations in temperature cycles of the oceans, the Pacific and the Atlantic. Dr. Shinichi Akasofu of University of Alaska has said it's quite obvious that the temperature change during the last 100 years or so includes significant natural changes. It's very puzzling that the IPCC reports state that it is mostly due to the greenhouse effect. But what about sea level rise? Former Vice President Al Gore and Dr. James Hansen of NASA have warned of a 20-foot ocean rise by the year 2100. If that were to happen, it would flood our major coastal cities all over the world, quite a disaster. Well, to discuss that, we need to talk about Earth's 3 ice caps, the North Pole ice, the South Pole ice, and Greenland. And it is true that Arctic sea ice has been shrinking for the last 30 years, according to satellite data, or last 40 years or so. And some climate scientists say, oh, this is the canary in the coal mine. This proves that humans are causing dangerous warming. 3 things you need to know about Arctic ice, though. First, it naturally comes and goes. We have historical accounts of low ice in the past. Second, Arctic ice is floating on the Arctic Ocean. If it completely melts, it won't raise ocean levels at all. You can do an experiment with a glass of water and ice. Melting ice doesn't raise ocean levels. But third, this is only 1% to 2% of Earth's ice. So we need to, and this gets all the press, so we need to talk about the other 90%. It turns out, not 2 weeks after we had a minimum in North Pole ice, 2008, we had a maximum in South Pole ice. 2 weeks later, Antarctic sea ice has been growing for the last 40 years, same satellite data. And the climate models can't explain why this is happening. And if you take the Antarctic sea ice and the land Antarctic ice, this is 90% of Earth's ice cap. Interesting picture here of the Amundson-Scott South Pole Station. The United States has maintained a continuous scientific presence at the South Pole since the 1950s. This is the 3rd station at the South Pole. I'm sure some of you might know what happened to the other 2 stations. Anyone know? They were buried by snow. And the reason is, for the last several decades, Antarctic has been getting about 8 inches of snow accumulating every year, never gets above freezing, never melts at the South Pole, so it's 8 inches and it's 8 inches and it's 8 inches. It gets to be a little bit of a problem. You could see the second station right here, this black dome with the snow all up around the sides. And notice also this new station is 7 modular buildings and it sits on stilts. And the reason for that is every year they jack up the stilts, jack up the buildings over the accumulating snow to prolong the life of the station. Folks, this is the South Pole ice, 90% of Earth's ice, and it's getting thicker. If you watch PBS or maybe Canadian broadcasting, you might see a discussion about Greenland with a picture of a crevasse with the water pouring down and the hint that this is an abnormal event. But many scientists realize this has been going on for millennia. Greenland sits in a spot in a globe where there's melting in the summer and these rivers form and freezing in the winter. And I need to tell you the story about the P-38 Glacier girl. You can look it up online, but don't do it right now. In 1942, 8 planes took off from the United States to participate in the European theater, flying by the way of Newfoundland, Greenland, Iceland, Scotland, England. But when they took off from Greenland, they ran into a storm and they were forced to turn around and crash land on the Icecap of Greenland. And they abandoned the planes. All the pilots and crews were picked up by the Coast Guard. But then some 40 years later, people said, well, hey, we left those planes there, let's go back and recover them. But it took several expeditions, and finally they went back with sophisticated subsurface radar to find the planes. And this is a picture of the Glacier girl in an ice cave, and it was found buried under 268 feet of ice. Great story. They tunneled all the way down, hollowed out this cave, took apart the Glacier girl, brought it up. They reconstructed it. It's flown in air shows. But the interesting thing is from 1942 to 1992, 268 feet of ice accumulated on this shrinking ice cap of Greenland. Well, Greenland is actually melting a little bit at the edges and getting thicker in the center, but overall the ice is basically rock solid, very little change. So for sea levels, what does all this mean? If you go to the site of NASA, you can see that ocean levels have been rising for the last 20,000 years. They've risen about 120 meters or 390 feet. No climate scientist can tell you when natural sea level rise stopped and man-made sea level rise began. But tide gauges tell us the oceans have been rising about 7 or 8 inches per century over the last 150 years. So the good news is it's very unlikely we're going to see a 20-foot ocean rise. The bad news is that water ski Manhattan postcards are not going to be in big demand. But aren't natural disasters evidence of man-made climate change?
As CO2 levels rise, temperatures rise. The result, as the world gets warmer, the climate changes, and extreme weather events become more common.
Persuasive, but the data does not support Dr. Suzuki's assertions. This is a look at satellite data over the last 40 years. This is global. It shows the number of tropical storms and the number of stronger hurricanes. No upward trend. And this is also a measure of storm strength, because if tropical storms were getting stronger, we would see more hurricanes. Hurricanes would be rising. But it isn't happening. The United States gets about 90% of the world's tornadoes, and Canada gets most of the rest. If you look at tornado intensity, though, the number of EF3 or stronger tornadoes, you see that we had a lot of strong tornadoes in the 1950s, 60s, and 70s, and very few since. Number of tornadoes and the strength of tornadoes is not increasing. Back in 2012, we had the Great Plains drought in the United States and probably in Canada. 80% of U.S. agricultural land in drought. Dr. James Overpeck of the University of Arizona said, "This is what I and many other climate scientists have been warning about. This is what global warming looks like on a regional or personal level." But the U.S. government has very good data on the percentage of the U.S. that is either wet, very wet, or very dry. And I show you that in two graphs here. The top graph is the percent of the continental U.S. that's been very wet for the last 100 years. The bottom graph is the percent of the U.S. that's been very dry. You can see no trend of increasing drought or flood. And take a look at 2012, 2013. Oh yeah, isn't that evidence that humans are causing dangerous climate change? We all want clean air and water, don't we? For more than 30 years, I had the joys of kayaking some of the great whitewater rivers of North America, including your Ottawa River. And our air and water is very much cleaner than it has been for decades. But now we're conflating real pollutants and carbon dioxide. And the news media, the U.S. Environmental Protection Agency are now declaring that carbon dioxide is a pollutant, and also major political leaders.
The government proposes that the price on carbon pollution should start at a minimum of $10 per ton in 2018, rising by $10 each year to $50 per ton in 2022.
Ladies and gentlemen, that is bizarre. Carbon dioxide is not pollution. It's an odorless, harmless, invisible gas. It does not cause smoke. It does not cause smog. What you see rising from the cooling tower of that power plant, that's not carbon dioxide. Can't see carbon dioxide, that's condensing water vapor. We inhale only a trace of carbon dioxide from the atmosphere, but as we burn sugar in our body, we create it. So with every breath, every time we exhale a concentration that is 100 times what we breathed in. Now I have another question for you. What do cannabis growers know that Prime Minister Trudeau doesn't apparently know? I think I heard the right answer out there. CO2 makes the plants grow. Any marijuana grower worth his or her salt pumps carbon dioxide into the greenhouse to make their crop grow bigger. You can see that canister on the left there, that's carbon dioxide, and that device up at the top there, that's a CO2 generator. CO2 is green, carbon dioxide is plant food. It's essential for life on Earth. Hundreds of peer-reviewed studies show that carbon dioxide makes plants grow bigger and faster. Here's a graph of the world's top 7 food crops. They grow between 20 and 60% bigger with higher levels of atmospheric carbon dioxide. Plants get bigger fruits, they get bigger vegetables, they get thicker tree trunks, they get bigger root systems. They're more resistant to drought. If there's one compound we could put into the atmosphere that would be great for the environment, carbon dioxide is that compound. Yet today we have every university and every business trying to reduce their carbon dioxide footprint. Very, very foolish.
97% of scientists, including, by the way, some who originally disputed the data, have now put that to rest. They've acknowledged the planet is warming and human activity is contributing to it.
Well, I'm picking on everybody today. And there's that statement again, the planet is warming and human activity is contributing to it. Oh boy, that's... Well, I got to talk about this 97%. It's very unfortunate that our former President of the United States has used this. There are many, many studies on this. All of them are flawed. Here's one example. Back in 2009, Duran and Zimmerman did an online survey with the American Geophysical Union. They sent out surveys to 10,000 members. Those are the geologists of the United States. They received back 3,100 responses. They asked 2 questions. The first was, when compared with pre-1800 levels, do you think that mean global temperatures have generally risen, fallen, or remained relatively constant? Well, you all know the answer to that. We've been coming out of the little ice age. They've been warming. Second, do you think human activity is a significant contributing factor in changing mean global temperatures? A very fuzzy question. They didn't say, is it the main factor? Is it a dangerous factor? Just is it significant? Then they threw out 3,000 responses because they said, these aren't climate scientists. And of the 77 that responded, 75 of them said it's been warming and it's significant. So this is the opinion of 75 folks. I hold in my hand a copy of the Global Warming Petition, which was done in 2007 by the Oregon Institute of Science and Medicine. There's a little bit of climate science in the front, but then there are the names of 31,000 American scientists, 9,000 PhDs, and I'm going to read you what they said. There is no convincing scientific evidence that human release of carbon dioxide, methane, or other greenhouse gases is causing, or will in the foreseeable future, cause catastrophic heating of the Earth's atmosphere and disruption of the Earth's climate. Moreover, there is substantial scientific evidence that increases in atmospheric carbon dioxide produce many beneficial effects upon the natural plant and animal environments of the Earth. So don't believe that 97% nonsense. So the bottom line of all this is that climate change is natural, not man-made. I don't have a chance to go into a lot of the details, but it's due to natural cycles of Earth that are probably driven by the sun. Man-made greenhouse gases play only an insignificant role. Well, let's go on to renewable energy. As Mr. Lyman said, all of the developed nations of the world are seeking an 80% emissions cut by the year 2050. The goal for the United States was an 83% reduction from 2005 levels. In 2005, if you divide up all the emissions, each U.S. citizen was responsible for 1.5 tons of carbon dioxide, and that's from our heating and our cooking and our transportation and our agriculture and our industry, everything that we do. It turns out to meet this goal of an 83% cut, we'd have to forego all of our modern appliances and go back to a level of 0.2 tons of carbon dioxide per person. To give you a comparison, the nation of Nigeria today emits about 0.2 tons of carbon dioxide for each of its citizens. But 40% of the people in Nigeria don't have access to electricity, and there's only 3 cars per 100 people in Nigeria. But some say that renewable energy is the answer. WeCanSolve.org 11 years ago said repowering America with 100% of its electricity from clean energy sources within 10 years. And then we had this headline from the Wall Street Journal in 1978, solar power seen meeting 20% of needs by 2000. But as was mentioned previously, still 80% of our power, 70% in the case of Canada, comes from hydrocarbons. This is a look at the Canadian energy consumption for 2014. 30% from oil and natural gas liquids, 34% from natural gas, 8% from coal, 11% from hydro, 10% from nuclear. Other renewables were only about 6.2% despite decades of incentives. And if you break down the renewables, almost all of that was burning wood and biofuels. Hey, that's the, biomass is the technical term, right? And take a look at this. I call this the energy mountain. This black graph shows global energy consumption, which has tripled since 1965. So what I've plotted on here is the amount of wind and solar. And I had to artificially enhance the solar line so it would even show up. Wouldn't even show up. Every year, the world adds another United Kingdom worth of energy consumption. And wind and solar can't even provide for the increase, let alone replace our traditional fuels. But we're sure trying. We've got a lot of things going on around the world. In Germany, we have solar mania. In the 1990s, Germany put in a feed-in tariff, which I think you have in Quebec or Ontario. And they said they would pay each German citizen that put solar cells on their roof 8 times the current market price and guarantee it for 20 years. What a great deal. And so they had an explosion in rooftop solar systems. Over 1 million. But Germany's not actually the Sun Belt. Actually, when I speak to other groups, I always say, yeah, central Germany is about equal with Calgary, Canada. So they get very little output. About 10% of the rated output in 2014 was a good year. Those solar systems provide 1% of Germany's energy and 6% of their electricity at a fantastic cost. Already $400 billion in subsidies paid and obligated. And the environment minister in Germany says the subsidies alone are going to total €1 trillion by the year 2040. Jürgen Grossman, CEO of energy utility RWE, to produce solar power in Germany is as sensible as to grow pineapples in Alaska. Or in Canada, maybe. In Denmark, they have climate madness in the form of wind turbine towers. Denmark has erected 5,000 wind turbine towers, 1 for every 1,000 citizens, the highest density in the world. And I've plotted all those wind fields over here on the graph on the left, all those black dots. Today, if you're a backpacker, you can walk from one end of Denmark to the other and never lose sight of a 300 to 500 foot tall wind turbine tower. Now, you'd think wind turbines put out a lot of electricity, but you'd be wrong. They could all be replaced by a single conventional power plant with a footprint about as big as one of those black dots. And a little bit of a complicated graph here. What I've done, on the vertical axis is the wind and solar capacity of each nation in Europe in watts per person, and along the horizontal is a residential electricity price. And you see a pretty good curve there going up to the top. The more wind and solar you put in, the higher your electricity prices. In Spain, they're now paying 3 times the Canada price, and in Germany and Denmark, 4 times the price of electricity in Canada. Does solar provide a net energy gain? Interesting question. Study done last year by Ferroni and Hopkirk for solar systems in Germany and Switzerland found that after you build the solar cells, put them in panels, construct them on the site and maintain them, and then you figure out how much energy, this analysis is called energy received over energy invested, I should say. The energy invested turns out to be bigger than the energy received. You only get 82% of the energy out that you put in. And I've translated this to North America. That 35-degree north latitude line is the break-even point. Anything north of there doesn't get as much energy out as you put in. So in Canada, if you're putting in solar cells, you're paying for a lot of energy to be expended in China or somewhere, and you never get it out over the 25-year life of the system. And anyone know biomass energy's big secret?
Doesn't work without subsidies.
Doesn't reduce CO2 emissions. Everyone knows that if you burn wood, you put carbon dioxide into the atmosphere. But the Intergovernmental Panel on Climate Change ruled in 1996 that burning wood or biomass or biofuels was carbon neutral. And the way they made that assumption was they said, well, plants grow and absorb carbon dioxide. You cut them down and you burn them, and they release carbon dioxide. It's an even wash, carbon neutral. And so emissions from carbon dioxide, when you hear these numbers, they don't even count them in Canada, in the United States, in Europe. All those numbers are wrong. They don't count emissions from biofuels. But scientists recently have said, well, this logic is flawed. Because if you have land, plants will naturally grow and absorb carbon dioxide, even if you're not doing anything with biofuels. And if you're not counting that, you end up double counting. So there's a big error. Biofuels do not reduce carbon dioxide emissions. But nevertheless, we have crazy stuff going on. Consider the Drax power station in England, the biggest power plant in Europe, 4 gigawatts of power. Formerly, it consumed all coal, 140 coal trains a week to power this station. But because the United Kingdom and the European Union don't count biomass emissions, they converted half the plant, to wood. And because they don't have enough wood in Europe or in the United Kingdom, they're shipping it 3,000 miles from North Carolina. And this cost $1 billion to convert this half of a plant. They're getting a subsidy of £1 billion a year, and they've doubled the electricity price for British consumers. But in Argentina, they've found the ultimate solution for emissions from livestock. Look at that poor Bessie. Well, I do have some good news today. And the good news is that there is an upheaval coming in energy and climate regulation. And there are a number of leading indicators which show that it is so. The first is the Renewable Energy Industrial Index, the RENIX index of the world's top 30 companies. Set up in 2002. It peaked in 2008 when Al Gore and the IPCC won the Nobel Peace Prize for their work in climate change. But since then, it's down about 80%. And today, it sits below what it was 20-some years ago. Carbon trading markets are failing. The World Bank used to put out a glowing report up to 2011 on how well those carbon markets were doing. But the last 4 years they haven't issued that report because the value crashed, and it's now a third of what it was in 2011. Global investment in renewables has basically stopped or slowed. It grew 30% a year up to 2011. Now it's basically flat for the last 5 years or so. And Europe's investment in renewables is down 50% since 2011. Employment in renewables is down in Europe. It's just too expensive. They can't afford the subsidies anymore. And Europe is slashing subsidies and mandates in England, Germany, Belgium, Spain, Italy, Netherlands, Greece, Czech Republic, all across the continent. And the province of South Australia has recently had 2 wide area blackouts in the last 6 months. It used to be that the mark of an underdeveloped nation was electricity blackouts. Now that's a mark of a nation that puts in renewables. And coal plants are in internationally. 2,400 coal-fired power plants are in planning or under construction. Almost 1,200 in China, almost 500 in India. Plants in Vietnam, Indonesia, Philippines, Turkey, South Africa. Even Japan is building 45 new coal-fired power plants. So what you do in Calgary or even in Canada has no bearing, nothing to do with the state of global emissions. And this is Mick Mulvaney of the Office of Director and Budget. You got to listen closely here. Press conference a month or so ago.
The question as to climate change, I think the president was fairly straightforward. Is that we're not spending money on that anymore.
Very, very refreshing. Yeah, there's a big 180-degree shift. President Trump has taken climate change off of his website, the EPA website. He's proposed a 31% cut for the EPA, climate cuts in the State Department, NASA, NOAA, renewable energy cuts in the Department of Energy. Really a big change. He has postponed his decision on whether to withdraw from the Paris Accord till the end of May. I'm hoping he does. There's an opportunity to throw a huge rock in the happy climate pool of all these world leaders. And if he does so, we're going to have other leaders rethink their commitment. And this is an emperor has no clothes situation, folks. We need someone to stand up and say this is nonsense, and maybe a bunch of others will say, yeah, I agree. And climate scientists are telling us it's likely we're going to be in for a period of cooling. The 2 big ocean currents of the Pacific and the Atlantic are moving into a cool phase. And many climate scientists think that solar activity on the sun, sunspots and other activity affects global temperatures. The sun is very inactive now, which portends cooler temperatures. So we'll just have to see. But in any case, the Earth and the temperatures are going to do what they're going to do naturally, and the climate models are going to get farther and farther from the real situation. So in summary, the evidence shows that climate change is dominated by natural factors. Water vapor is Earth's dominant greenhouse gas. Humans are responsible for only 1 or 2 parts in 100 of Earth's greenhouse effect. There is no law or no tax that your leaders in Ottawa can put into place that will stop the oceans from rising. There's no regulation that any province can put into place that will make the storms less severe. Because climate change is dominated by natural factors, thousands of laws across hundreds of nations are unlikely to provide a measurable difference in global temperatures. Just a couple things you can do here. One is educate yourself. A great image here from a couple years ago. The woman on the left is the head of the Department of Meteorology and Climate Science at San Jose State University. The guy on the right is one of her scholars. If you look closely, you can see she's holding a match under my book. And they put this up on their website. It was up about 3 hours. I think about 20 articles were written on the web about this. But the universities don't want to hear the crazy idea that climate change could be driven by natural rather than man-made factors. Second, educate your company. I have a great afternoon-long program called Energy and Sustainability, a Minority Report. For your board of directors, your policy committees, or whoever, there's a lot more to tell. And with that, I'll wind it up and look forward to your questions and challenges.